Hello, and today's video we're talking about pizzazz page 49. We're going to discuss the odd numbers in this video on pizzazz page 49, so numbers 1, 3, and 5. Please make sure you add your name and date to the top of this. And let's go ahead and take a look at the first problem. The first problem says the second of three numbers is 8 more than the first. And the third number is 3 more than 3 times the third. If the third number is 15 more than the second, find the three numbers. Now when we tackle a word problem like this, we're going to start with identifying what our three unknowns are. In this case, we have 3 of them. And in this case, they're numbers. And so we have 3 unknown numbers. So our first number, second number, and third number are what we're going to identify as the things that we don't know that we're going to put variables to. So because I have first, second, and third, I might as well just use x, y, and z for the first, second, and third respectively. Now the next thing I'm going to do is I'm going to go ahead and chunk the word problem out. So I just read the whole thing through and there's a lot of information. So I'm going to chunk it into smaller pieces that make sense to me. So here, it says the second of 3 numbers. So the second is the same thing as y. And is the same thing as equals. 8 more than means 8 plus. And the first is x. So I can write where I see y down here. I can write y is equal to 8 plus x. And that's my first equation that we've been given. Still in the first sentence, I can write another equation. And the next equation I can write is, it says, and the third number, so I'm right here. And the third number is, well, the third number is z, and is means equals. 3 more than 3 times the first. 3 more than is 3 plus, and 3 times the first, well, the first is x, so I can write 3 plus 3x. So I'm going to pop that down where I see z in my original ideas down here. So z is equal to 3 plus 3x. Now I have another sentence that I can go ahead and look at for a new equation. It says if the third number is 15 more than the second. The third number is represented by z, and is means equals. 15 more than is 15 plus, and the second is represented by y. So z is also equal to 15 plus y. Now this is interesting. I have 2 things that z is equal to. So it lends itself, based on equality, that if z equals to both of these things are equal to each other. So I can write 3 plus 3x is equal to 15 plus y, because they are both equal to z. Now we can think of this like $1 is equal to 4 quarters is equal to 10 dimes. So because of that, 4 quarters is also equal to 10 dimes. And that's how we're taking a look at this here. So let's go ahead, and if these 2 things are equal, we can write them. And actually, because y we know is the same thing as 8 plus x, we're going to substitute 8 plus x where we see the y. And now all of a sudden, we have an equation with only one variable in there. There's only x. And this allows us to solve for the value of x. So doing this, I have 3 plus 3x, and that cannot be simplified. But on this side of the equation, on the right, I can take 15 and add 8 and get 23 plus x. Now going from here, I can solve. So I'm going to want to move the x's onto one side. It makes sense for me to move them onto the left side. So I get 3 plus 2x is equal to 23. Subtract 3 from both sides and get 2x is equal to 20. This then tells me that x is going to be equal to 10. I can also do the math by dividing both sides by 2 and find that in fact x is equal to 10. So in doing this, if x is equal to 10, I can go ahead and find out what y and z are respectively. So let's go ahead and go back to the equation of the second number where y is equal to 8 plus x. So if I have the idea that y is equal to 8 plus x, I can say that y is equal to 8 plus 10, and so therefore y is equal to 18. Similarly, I can also say then that z is my third number, and z is equal to, let's see if I can find this, either 15 plus y or equal to 3 plus 3x. So I can go ahead and say I usually like to work with x's better. They tend to make more sense to me sometimes. It doesn't matter which equation that you use, either this equation here or this equation. Again, they're both equal to z. So I'm going to use this idea of z, let's go back to the pen, of z is equal to 3 plus 3x. And then that means that z is equal to 3 plus 3 times 10, which is 30. So then that means that z is equal to 33. Now, that tells me that I found all three of these numbers. And I'm going to go ahead and make sure that on the page that these three numbers match up to my pizzazz answers. In this case, it's a little bit more challenging to double check if the answers are correct. But I can go ahead and make sure that if z is equal to 15 plus y, I can also check that 15 plus 18 is equal to 33. And in fact, it does check out. So there's a couple of options for us as to how we can go about checking in a situation like this. It's more of an intuitive check. So I want to double check. It asked me to find the three numbers, and in fact, I was able to find the three numbers that work out. So we're going to go ahead and move on to number 3. The third problem on pizzazz page 49 discusses Model Cars Inc., or Incorporated, is what that stands for. So Model Cars Incorporated makes red cars, white cars, and blue cars. The profit on a blue car is $10 more than the profit on a white car. And the profit on a red car is $7 less than the profit on a white car. If the profit on 2 red cars is $2 less than the profit on 1 blue car, what is the profit on a blue car? Now, again, don't take it all in at once. Take pieces. So what we're going to do is we're going to identify again what the three things, in this case there are three, there's 3 different types of cars that we don't know. Our ultimate goal is to find out what the profit is on the blue car. So we're going to go ahead and identify that we want profit to know on the red, white, and blue cars. So we're going to write that down as our identifying the variables. Okay. Profit on the red car. Profit on the blue car. Actually, white, I guess, showed up first, so let's use white next. And then the profit on the blue car. And because we have 3 things, again, I'm going to use x, y, and z. It doesn't matter that we use these variables, but we need 3 different variables to identify the profit for each of these things. So if we talk about that, then the next thing we're going to do is to chunk out the information that we were given. So we know they make three different colors of cars rather. And the first thing that we're told then in the next sentence is that the profit on the blue car, well, we indicated that to be Z, is means equals $10 more than, so we're going to write 10 plus the profit on a white car. And the white car we're going to represent using the letter Y. So we can then essentially write our first equation of Z equals 10 plus Y. So let's go ahead and write that down here, 10 plus Y. The next thing that we're given is the information to say the profit on a red car. Now we're recognizing the profit of a red car to be X. Is means equals 7 less than the profit on a white car. Now whenever I see less than, I know I need to reverse the information. So the white car we indicate with a Y. And 7 less is the same thing as saying minus 7. So in doing that, I'm going to write X is equal to, I can either write minus 7 plus Y, or I can write Y minus 7. So let's take a look. I think it makes more sense to do the X is equal to Y minus 7. Most of us use that formation when we see less than. Again, less than is the key in which we have to reverse them. The next thing we're going to take a look at says, if the profit on 2 red cars, okay, well, 2 red cars would be 2x. Is would mean equals $2 less than the profit on 1 blue car. Well, the blue car we write as Z, and $2 less we can write as minus 2. So here's an idea. We can write this new equation as 2x equals Z minus 2. And again, we can use Z minus 2 or negative 2 plus Z. It's your choice. And the identifying factor that we're wanting to find out here is what Z is equal to, because Z is representing the profit on the blue car. Now, I'm going to do a lot of substitution here. And when I substitute, it's going to indicate a couple of pieces. If I know that, and let's start back. If I know that X is the same thing as Y minus 7, I can substitute Y minus 7 where I see X. If I know Z is the same thing as 10 plus Y, I can write 10 plus Y where I see Z. So let's go ahead and actually pop in those expressions for X and for Z. Again, where I see X, I'm going to write in Y minus 7. And where I see the Z, I'm going to write in 10 plus Y. Now I have a distributive property that I need to simplify first before I move on. So I'm going to go ahead and do that. And I get 2y minus 14 is equal to, and I can simplify this right-hand side here by taking the 10 and the negative 2 and finding out I get 8 plus y. I have variables on both sides, so before I do anything else, I need to move my variables from the right over to the left. So I'm going to subtract y from both sides. So I get y minus 14 is equal to 8. From here, I'm going to add 14 to both sides. And that doesn't quite seem right because I would get a negative value for that. Oh, no, I wouldn't, because I'm adding 14 to both sides. Good. I thought I was subtracting for a moment. This would give me y is equal to 22. So that would be the cost, or rather the profit. We're working with profit. The profit for the white car is equal to $22. So that's interesting, but that's not exactly the question we were asking. The question we were asking is, what's the profit for the blue car? And the blue car has the equation of z is equal to 10 plus y. So I can rewrite this over here and substitute in for y that 22. So z is equal to 10 plus y. So then z is equal to 10 plus 22. So that tells me z is equal to $32. And that makes a very nice, simple equation. So I'm told that the profit on a blue car, so I'm going to write it in a sentence. The profit on a blue car is $32. Now let's take a look at the question number 5, and that has to do with hamburgers, hot dogs, and cheeseburgers. Kind of makes you hungry. This 5th question says a hamburger costs 30 cents more than a hot dog and 20 cents less than a cheeseburger. If 3 hamburgers cost 75 cents less than 2 hot dogs and 2 cheeseburgers, how much does a hamburger cost? So the ultimate goal is to figure out how much just the hamburger costs. And the 3 things that we don't know are the hamburger, the hot dog, and the cheeseburger. So I'm going to shorthand hamburger, hot dog, and cheeseburger by saying ham, HD for hot dog, and CH for cheeseburger. And because I have 3 things that I don't know, I'm going to use again X, Y, and Z. And start off with the first chunk. So it says a hamburger costs. So it's telling me a hamburger is equal to when it says costs. So if I get to do that, I'm going to go ahead and say a hamburger, which is X, costs, which in this case means equals 30 cents more. Now, as long as I know that I'm working with cents, I'm going to leave this as actually a whole number instead of making it a decimal. So 30 more is going to be 30 plus a hot dog. And a hot dog is Y. So I know that X is equal to 30 plus Y. Similarly, I was told that it's also equal to 20 cents less than a cheeseburger. And so still, I'm working with the idea of a hot dog, I'm working with the idea of a hamburger. So I know that X is also equal to 20 cents less than a cheeseburger. So that tells me that I'm taking the cheeseburger, which is Z, and I am subtracting 20 from it. So it's the same thing as saying Z minus 20. And if I do that, it's also another way of saying I can essentially solve for Y when I take a look at this. And in order to do that, if I have something, a hamburger, costs 30 cents more than the hot dog and 20 cents less than the cheeseburger, the difference between the hot dog and the cheeseburger is 50 cents. So I know then that the hot dog is 50 cents less than the cheeseburger. So in doing that, I can also do it mathematically. Intuitively, that's what we find out. But mathematically, I can prove that to you by saying, if I want to solve for Y, I could say subtract 30 from both sides, and I would get Y is equal to Z minus 50. So that helps us intuitively check that our mathematics can make sense. So in going ahead and doing that, I'm going to write down that y is equal to z minus 50. You can either do that intuitively or you can do it the mathematical way of solving for y. Now from here, if I know that, I can go ahead and substitute that involved in here when I get all these pieces organized. The next step, I still have another sentence to translate. The next step is to translate if 3 hamburgers cost 75 cents less. Excuse me. If 3 hamburgers cost 75 cents less than 2 hot dogs and 2 cheeseburgers. So I can write that by saying if 3 hamburgers, that's the same thing as saying 3x. Costs. In this case, that's our equal sign. So let's go ahead and write that down just so we don't forget that. 75 cents less than is the same thing as saying minus 75. So I'm going to put that on the end here. 2 hot dogs. Well, hot dogs are y, so I can write 2y. And means plus. 2 cheeseburgers. And that means 2 times z, because cheeseburgers are represented by the letter z. Okay, now with this, I've got a whole lot of information going on. But for x, I can substitute in and make that equal to z minus 20. I'm going to use the other one over here because I have 2 different options that I can use. So if I plug in 3 times z minus 20 is equal to 2 times, and y we know as z minus 50 plus 2z minus 75. Now from here, I'm going to ask that you continue on and finish this on your own. Make sure you distribute when you need. Simplify to make each side as easy as possible to work with before you start moving terms from one side to the other. Remember, our answer here is in cents. So if you get something over 100 cents, you're going to recognize that it's $1 and that many cents, right? So double check what you've got going on, and good luck. We will continue working with this in class. Thank you so much for your time.